Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Nothing But Arrows by Railman, and here are the rules. We have normal Sudoku rules applied, which means place the digits 1 through 9 once in every row, column, and box. And we have arrows, where digits on an arrow sum to the number in the attached circle. So, for example, say this was 4 and 4. This would have to then be 8, because the digit in the circle must be equal to the sum of the number, must be equal to the sum of the digits on the arrow. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, this is the sum of 3 unique digits, so it must be 6 through 9. This is the sum of 3 unique digits, but it has 6 digits that are definitely smaller than it. And one of those digits has to be at least 6. So you're guaranteed 1 and 6 with a 1 in it. So it has to be 8 or 9 here. And this is a similar setup here. So this also must be 8 or 9. These digits are all smaller than it, but they all have an additional digit added to it. The sum of these, okay. What is the sum of these 6 digits? It's at least 1 through 6, which is 21. The sum of these 2 digits is at least 3 because they're in the same column, so it's 1 and 2. The sum of these digits are at least 3 because, again, they're in the same box, so that's 1 and 2 at least. So 21 plus 3 plus 3 is 27 at minimum for the sum of these 3 arrows. Well, these 3 arrows must sum up to this digit 3 times. So that's 3 times whatever that digit is. 8 times 3 is 24, which is too small. So this has to be 9 times 3. And these have to be the digits 1 through 6. Because that adds up to 21. These must be adding up to 3, so it's 1 and 2. And these must be 3, so they must be 1 and 2. Therefore, we know this is the same thing, right? So this is 9. This is 1 through 6 here to add up to 21. This is 1 and 2 to add up to 3. And this is 1 and 2 to add up to 3. Okay. So this is okay, so this can never be 1 or 2. This can never be 1 or 2. So at minimum, this is 3, 4 with 1 or 2 here. So it has to be at least 8 or 9. And this is at least, this has to be 3, and it's either with 4 or 5 here to add up to 8 or 9. Because you can't have 1 or 2 because of the 1, 2 pairs in the box and the row and the column. Should we start coloring these? Maybe. Let's make this yellow and orange. Since this is yellow, this can't be yellow. This is orange, which makes this yellow, which makes that orange, which makes this yellow. Yellow means this is orange there. Orange means this is yellow there. Okay. Remaining digits in this upper right-hand box are 7 and 8. Same with this lower box. So this has to be 3 or 4 or 5 here. This can't be 3, right? Because we of the 1, 2 pair in the boxes, you cannot be 1 or 2. And you can't have 6 here because 6 with 3 adds up to 9 at least, which is too big. This can't be 3 because of the 3, 4, 3, 4, 3 being in this column. So the rest of the box then is 6 through 9 here. Obviously, so this has to be 6 and 3 because this is at least 6 because of a 3, 4, 5 triplet in the box. And therefore, this must be 6 and 3. So we have 6 and 3 here, adding up to 9. So no 6 here in this rest of the central box. No 9 here. This can't be 3. This is at minimum 4 and 4, which add up to 8. So this has to be 4 and 4. So we have 4 and 4 here. This is orange, which means this can't be orange. This must be yellow. 4 and 4 add up to 8. So this is 8. That's 7. This can't be 4 anymore, so this is 3, 5 as a pair, which plus 1 adds up to 9 at minimum. So then for yellow must be 1, orange must be 2. Okay, this can't be 1 here. So this must be 1, 2, 6 or 1, 3, 5, adding up to 9. This is 2, so these must add up to 7. So 1, 6 could be here, but it would have to be 6 and 1. 2, 5 could be here if that's 2 and that's 5. But you can't have 2, 5 here because that would eliminate all possibilities for this pair here, right? Again, this is 1, 2, 6 or 1, 3, 5. So no 2 and 5 here. This has to add up to 6 here without, so because of this is 3. So this adds up to 6. So it's 1, 5 here, or it's 2, 4 here. Same here. This is 1, 5 or 2, 4. No 1 here because this can't be 1, so this can't be 5. So this is 2 or 5. This is 2 or 5, so this is 1, 6, or it's 3 and 4. 2 cannot be here, so 6 can't be there. This is adding up to 7. And it cannot have 1... It could be 1, 6. Okay. So if it's 1, 6, this is 1, and this is 6. If it's... Otherwise, it's 3, 4. And this would be 3, and that's 4. So we have 1 and 4 here. This is 1 or 4. So we can't have 1 or 4 here. This adds up to 8 anyways. So it's 2, 6, or 3, 5. So no 2, which means this can't be 6. No 3 here, which means this can't be 5. Okay. Remaining digits of row 6. We have 5, 7, and 8. Okay. This cannot add up to 9. And it's at least 3 and 5, which adds up to 8, which is the most this can be. So this has to be 3 and 5 as a pair, which eliminates 3 and 5 in the rest of the box. This can't be 5 anymore. So the remaining digits in the box are 6, 7, 8, 9. 9 cannot be here, so 9 is here. 3 and 5 add up to 8, so this is 8. This can't be 8 or 9. It's 7, which makes that 8, which makes that 9. Remaining digits, 8 eliminates 8 here, so it's 7. This can't be 7 or 8. It's 5, which eliminates 1 and 5. Wait. This adds up to 7. How do I get that? So this would... No, this is 6. Right, never mind. Can't be 2 and 1 and 5, so this is 2 and 4 here, which eliminates 2 and 4 in the rest of the box. So this is 5 and 3. That leaves this as 1 and 6. Okay. 5 plus 1 could work to add up to 6. 5 and 3 could work. It can't be 2 or 4 because of 2 or 4 pair in the column. 5 and 3 could add up to 8, so those could work. And where are the 1 and 3 in column 9? They can't be here or here because of 1 and 3 in the boxes. They can't be here because they must add up with 5. They must be the sum of something that adds up with 5. So 1 and 3 are here. This 1 eliminates 1 here. So this is 3, which makes this 1. 5 and 1 add up to 6. So we have 3 in the corner. We celebrate because we know we're close to solving it. 1 eliminates 1 here, so this is 3 and 4. That means this cannot be 3, 5, so this is 2, 6. This can't be 2, 4, so this is 1, 5 there. 1 eliminates 1 here, so this is 5 and 1. 3 eliminates 3 here, so it's 5 and 3. 5 eliminates 5 here, so it's 3 and 5. 8 eliminates 8 here, so it's 7 and 8. And everything else we just do from normal Sudoku. We have 8 ones. We know where the last one has to be. It has to be there. We can remove the colorings. 2s. 2s is pretty not restrictive. So 2 could be here. 2 is obviously one of these two. 2 can be one of these two, and 2 is one of those two. So pretty unrestrictive. 3. 3 is also pretty unrestricted. Could be one of those two. Can be one of these two. And one of these two. Let's not go number by number. That's not going to be the easiest way of solving it. Column 9, we are restricted to 2 digits, and it has to be 7 and 8. This can't be 7 because of 7 in the row. So this is 8, that's 7. Remaining digits of row 4. We have 4 and 6. This can't be 6 because of 6 in the column. So this is 4, that's 6. Row 5, we have 8 and 6. This can't be 6 here because of 6 in the column. So this is 8, that's 6. Column 3, we have 8 and 9. This can't be 8 because of 8 in the row. So this is 9, that's 8. Column 1, we have 2, 3, and 4. Ugh. So this can't be 2, this can't be 3. Column 2, we have 5, 6, 7. This can't be 5 or 7 because of 5 or 7 in the row, so this is 6. No 6s here. Column 7. Yeah, let's do column 7. We have 2, 7, 9. And this can't be 2 or 9 because of 2 or 9 in the row, so this is 7. This is 2, 9 as a pair. Column 8. We have 4, 5, and 8. This can't be 5 or 8, so this is 4, which leaves this as a 5, 8 pair. Row 2. No, row 3. We have 6 completed digits. We have 2, 3, 4 remaining. This can't be 2, so this is 3 or 4. Row 1. We have 3, 4, 5, 7. No 4 or 7 here. No 3 or 5 here. So that doesn't really help us much. We have a 2, 4, 2, 4 pair in row 2, so we are left with 5, 6, 7 remaining. And this can't be 6 because of 6 in the column. So this is 6 here, and this is 5, 7. Column 4, we have 3, 5, and 9. And this can't be 3 or 5 because of 3 or 5 in the row. So this is 9. And this is 3 or 5. 9 eliminates 9 here, so that's 2 and 9. 2 eliminates 2 here. So where is the 2 in this box? It must be there. Remaining digits in row 7. We have 6 and 7. 6 can't be here because of 6 in the column, so that's 7, 6. 7 eliminates 7 here, so it's 5, which makes this 3, which makes that 4, which makes that 2, which makes that 4. 4 eliminates 4 here, so it's 7, which makes that 5 and 7. 4 eliminates 4 here, so it's 2. This can't be 3 either, so it's 4, which makes that 3. 3 eliminates 3 here, so it's 5 and 3, which makes this 8 and 5. And that leaves the remaining digits as 8 and 4. So, fairly straightforward. It's more of a matter of seeing where the restrictions are, right? And oftentimes you'll have something similar to the way that these arrows worked, right? Where you'll have these arrows, the digits in the arrows add up to a certain sum, and that's restricted in other ways, right? And it's kind of vague how I'm explaining this, but oftentimes you'll have to basically see that you'll be able to find a way to add certain numbers together, and that will add up to a certain sum somewhere, right? So in this case, it was basically these digits had to add up to 3 times this one. And the way that worked then is, since these are all in the same box, you can't have repeats there. So it has to be 1 through 6 at minimum. This can't be repeated, so it has to be 1 and 2 at minimum, and this must be 1 and 2 at minimum. So therefore, that restricted what this could be. This therefore must sum to 27 at minimum, which is the maximum this digit could be times 3. So that's the reason why you can do similar things with those restrictions. Um, yeah, this was a nice little puzzle showing that, which is nice. Which is good. Anyways, I hope you enjoy this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.